Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. And the transformation can be personal, professional, transformation can be on a large scale, small scale. And Jay Dawani embodies all of this. I got to know him when I heard him at Silicon Catalyst, and he's doing amazing things. Jay, tell us, how did you become the Jay Dawani we know today?
I grew up in Karachi. I was there till I was 18. So most of my early education happened there. That's where most of my worldview was formed. I was a bit of a deviant in that I didn't accept things for where they were. I kept thinking about what could have been. I blame movies for that, especially sci-fi movies. That was my escape from the chaos of that world. I kept thinking about, well, beyond the clouds, beyond the stars. The Star Trek, The Next Generation, Star Wars, all those movies, the Jetsons, Kit, the Knight Rider cars, and all that. I kept thinking about what a world with all these technologies could look like. Back then, I wasn't really told that these things were actual careers. People work on these in real life. These aren't just fiction. One of my dad's friends encouraged me a lot. The reason for that is I was a troublemaker in school. Most of my teachers used to really, really dislike me because I kept asking questions and probing and challenging things. And so my dad was like, well, I'm just going to leave him with one of my friends who was also very curious. And he had a background in quantum physics from Brown and studied computers and a bunch of other things. He took to teaching me programming and AI and everything back when I was like 12 and 15 years old. And it helped me really understand advanced math and fueled me as like, hey, you can actually go pursue math. You're good at it. I'm like, well, I don't really want to do math, but I do want to pursue things like computers and AI, but because I find them really enjoyable. But even in school, we didn't actually have computers to program on. I learned to program C on paper by hand. I couldn't run the code and test it. I didn't really get to do that until much, much later when I actually did get a computer. But I was strongly discouraged to pursue a degree in computer engineering. When I was looking at applying to university, the program that stuck out to me was applied math. I'm like, if I get an applied math background, I can kind of go anywhere. With that, I can go into engineering later on, I can go into computers or wherever. I gravitated more towards financial mathematics at the point because I really wanted to see if I could crack the stock market. It just seemed like the biggest data set in the world and a representation of what every single person in the world is kind of thinking. So you have this herd behavior thing forming. I really wanted to go understand that. So I went to school for that. And turns out I hated the education system around how they were teaching it. I did not last very long. And I got very lucky in that when I came to Canada for university, the ImageNet moment happened and AlexNet was created and the entire world of AI was turned over. So I took a train, I went to Toronto and I waited for Hinton during his office hours and I just bombarded him with questions. He did not shoot me away. He did answer a lot of my questions and he encouraged my curiosity. I took that as a sign like, hey, I'm at the right place at the right time. I need to be part of this thing called AI. And it's finally working. I was really excited, not just because this thing is working, but because my dad's friend actually made me read Perceptrons by Minsky and Papert when I was 15. A lot of people misunderstood that book. So they showed the capacity of a certain size neural network at that time, because that is the amount of compute they had, the amount of data they had. But it was already showing signs of doing all these incredibly interesting things. To me, it was like the universal approximation theorem kind of says that if you have a network of infinite width, you can learn anything. And that's one of the most profound things in the world, that any learnable function, and given enough data and compute, this neural network can discover it and it can generalize. That is so powerful. People underestimate that. So I don't think it was really a surprise that neural network worked. I just think people underestimated the amount of compute and data that would be required. And now we're really starting to see that come into full steam. And I still think we're in the early days. My career, once I figured this out, was I don't want to research. I don't know if I can survive that world. I want to focus on trying to advance it from research and concepts into actual engineering that can be productized. So I kept looking for the companies that were working in these areas. I kept going towards startups because they had these fast-moving, chaotic environments that encouraged breaking things. And failure wasn't something that was frowned upon. It was actually encouraged, which was very foreign to me, but I liked it because I like breaking things, understanding them and building them back up. I got really, really fortunate in some of the applications I got to work on. I've got to work on robotics of space, on ground, underwater, in the air. And I've worked on high-frequency trading systems and all sorts of other things. I had a couple of startups where I tried to really push the boundaries, but I was a little bit too early, given where technology was at that time. And now I have another startup where I'm trying to solve the problems that prevented me from doing all the things I wanted to do earlier.
That's fascinating. It reminded me of my early days in AI, Perceptron. What do you guys do at Lemurian right now? How far do you think you'll be able to take the AI revolution to?
If we're successful, we create a world where AI is in abundance and it's being deployed in a way that is affordable and efficient, so that every single person on Earth has their own personal AIs that they're using to amplify them in every single kind of task. So you can see a personal AI for helping you out in household tasks, or working with you in an office on a set of tasks. A world where we have AI so that robotics go from these mechatronic machines where you build a new one for every single task to a general platform that new capabilities are delivered through with better and better neural models. There is a massive paradigm shift that is possible, but we aren't really there yet. We're seeing the early days. The biggest bottleneck to that has been compute. The estimate is today, if you deploy AI at scale, within 5 years, AI infrastructure is going to consume about 40 gigawatts. 40 gigawatts, if AI infrastructure was a country, would be in the top 5 consumers on the planet. It isn't something that is really efficient. Everyone's concerned about carbon and climate, and justifiably, they should be. Well, we have no way of actually offsetting these new carbon emissions. Similar to self-driving cars, if self-driving cars actually hit scale and you got to about the billion drivers or cars on the road today, you've effectively created something that consumes as much energy as data centers do today, which is about 3% of the world's energy. And that's assuming they use a certain kind of processor to get to level 5. These new applications and the electrification of everything and the AIification of everything results in a lot of energy consumption, which is going to overtax the grid breaks, and that creates a whole other bunch of problems. We started looking at all of this. I want to see a world where AI is in abundance. I do believe in that world, but that requires really rethinking the entire infrastructure for compute, from the software we have to make that more resilient. We can easily get about 2 orders of magnitude from just better software. We have another maybe order of magnitude to 2 from hardware. So we have enough there, but we haven't gotten it out because throughout history, things evolved in a certain way. So the incentive wasn't there for a very long time. So the era of unaccelerated software is what I call the last 2 decades, where we could rely on Dennard scaling and Moore's law to just give us more performance gains from hardware so that software didn't have to get faster. Forward and backward compatibility just allowed us to continue to pull in libraries from behind and just use that. And we still got faster gains. But now, when things aren't getting faster, when gate length is not really decreasing and memories aren't getting faster, you have to be more intentional about the software you write to get the most performance out. From a systems point of view, when you have something in abundance, you can be callous. But the moment resources start to become constrained, you have to maximize utilization. And that is where we're at today. We are completely memory bound. We aren't getting single digit to low double digit utilization on the existing hardware. That can all be fixed. So why haven't we fixed that? Because if we do, we break most of the software and how things have been done before. Now we're moving into this world where to get more performance, we have to go more and more domain specific and less general. We're going to have many different kinds of compute platforms. We move from homogeneous to heterogeneous. That breaks most of how software engineers think about writing code. We do not have platforms and runtimes to target these kinds of things. Conventional thinking was, let's just build new domain-specific languages for everything, right? And let's program each one individually. We've had SoCs for a while on mobile phones and everywhere else. But if we look at more software engineers, they don't utilize that. They don't know how. Performance engineering is a lost art. And by creating low-level frameworks, we're throwing away the entire value chain of compilers. So it is really that entire stack that we were looking at. That is what Lemurian is working on. We're trying to fix the entire compute stack to make AI available to every single person, so that not just 4 or 5 companies in the world can build and train large models, actually deploy them. Every single company has a level playing field and can get into that. We've been working on this for about 2.5 years now.
Exciting. What are the biggest stumbling blocks? Is it a heterogeneous compute and the lack of the software stack? Or is it the memory?
I don't think I can do anything on the transistor side. There's a lot of people smarter than me working in that industry. The roadmap looks to be 10 years strong for continued scaling and getting more density. There's a lot that has to get done, but computer architectures shift. I generally view the world as a system, and every single system has different parts, and each of those parts scale at different speeds and sizes. One of my most favorite examples is if you think about a mouse, and if you keep making a mouse bigger and bigger and bigger in size to the size of an elephant, it's going to end up collapsing in its own weight, because weight is this cube. So the bones are the cross section, so the area. They scale at different speeds. So after a certain point, the weight of the mouse collapses because the bone density isn't there to hold it up. That's why you need an entirely different musculoskeletal structure, which is what the elephant has, to hold it up and make it functional at that size. Computers are no different. Transistors scale at different speeds. Memories scale at different speeds. Networking scales at different speeds. And you need to still connect all of them up together. Wires also scale at different speeds. So that over time leads you into a different place in terms of the kind of architecture you should build. So we had these SIST or single instruction, single data kind of machines before, all the one architectures early on, CPUs. We had SIMD architectures, which eventually evolved into SIMT architectures, which is what GPUs are. But we still have the same request reply thing going on between the math and the memories. We have more communication than actual work happening, and that's where more energy is being spent. We need to think about how do we maximize the utility of the math and minimize the amount of time you spend moving memory around. That leads you to a different place. Same thing on the software. Once you're changing that, you have to rethink how you're scheduling and allocating work, and not just on a single chip, on a cluster of chips. Now, the computer isn't just the CPU and the accelerator, it is a data center. Software has to evolve for all these applications. And historically, whenever software has evolved, so have architectures, except for the last 20 years. Hardware has only adapted to try and meet the work, and they've done so remarkably well. But they are now starting to get to the point where things are starting to break. I don't know if there's a single area where I can say this is the problem. It's everything, but it has to be done in phases. So you can't just introduce a whole new chip all at once and be like, ta-da, I have this super powerful architecture, but I'm sorry, you can't program it. I'll figure out the software later. You also can't do, I have a great new architecture and I have a software stack. Sure, you can program it, but there's a very small set of people that actually want to go and rewrite all of their code, right? And that's usually a very small company or a hacker somewhere that really cares about this stuff for their own projects. But most companies that are doing production, you have to think about the software from their end and how they're currently writing code and what a migration path will look like to make sure it is seamless, or as close to it as you can get, because nothing is ever seamless, about how you get them productive on hardware. All of them are equally important, but the ordering of them matters a lot.
You brought up some really good points, especially that when you scale up, it's not just linear scale up. When the complexity goes towards the large cloud, some of it is private, you have complete access, but nobody else has access, and you got all these heterogeneous clouds. Wouldn't the same things apply? Do people who are building these clouds today, private or public clouds, do they have the tools that are needed to be able to create and scale up at the cloud level?
Yeah. If you look at the people who are building the hyperscale clouds, they have more than enough resources to build data centers. Now, it isn't just about getting computers or getting GPUs and networking and cooling. You also have to figure out the LAN situation. There's a whole bunch of things that you have to go on over there. Actually make sure that you have power to power up the data center and all the compute inside. That's when the fun begins. You still have to then be able to allocate enough work to it to actually make sure things work out over time, because the cost of everything inside of a data center, the total cost of ownership equation over there is amortized over a set of years, and it's different for every single company. Most data centers aren't just built in one locale, they're built in multiple different geographies, and each one has their own way of doing things. So it's a very complicated system in itself, right? And this is why things get fun. You're not just dealing with a system, you're dealing with a system of systems. You have to navigate all of them and understand it well enough to figure out, what does an end customer actually care about? What does their customer care about? What does that customer's care about? Then you kind of figure out what the common thread is, and that tells you what the valuable part that you're building is and what you should be focusing on. Because you can build the coolest architecture in the world, but if it doesn't solve that problem, it doesn't matter. People aren't going to shift. I might as well just go to wherever things work. I'll be okay with it. Because what most people misunderstand is it's not the cost of hardware that's important, it's the cost of human capital. You want to make the developers as productive as possible so that they can get more done in a smaller amount of time, because that creates more value. And computing plays a part in that. But it's always about the developer, because there's more lines of code written, and trying to navigate your way through that entire stack becomes really, really painful.
Very true. It's easy to say just throw resources, but then are we still being productive? Given that we have tools like machine learning, generative AI, and all that, how can these be used to, or will they be used to be much more productive? And if so, what will be the role of programmers and architects in future when these things become productive on their own?
This is something I've been thinking about for a very long time. In late 2017, I read a post by Andre Karpathy, who at that time was the director of AI at Tesla. It was really his post that made a light bulb go off in my head, which was deep learning isn't really just a tool in the workbench now. It is a new way of programming. Where you normally had a computer where you wrote a very rule-based deterministic code and you explicitly told the computer what to do, you now have a bunch of data with a cost function, and the neural network now figures out how to treat the data given that cost function. Now, The code is really the weights that the neural network has learned. So that in itself is the new program. And it's great for a different set of tasks. He characterizes this as software 1.0 and 2.0. So I was looking at this, I'm like, is that where it ends? Do we feed in an image or a task and it is just translated for us to tell us a classification of this cat belongs to this class, which is this kind of a cat or dog and so forth? I'm like, it doesn't feel that way. Remember early on I said, I really believe in scaling. Now, scale alone isn't enough. There's a lot of other things that are at play here. Also in 2017, we had the Transformer paper come out. And it stood to reason that if you can scale up a network enough, and these networks each learn different features in different parts of the network, there's this field of study called mechanistic interpretability, which has shown that neural networks tend to learn very similar features, and you can refer to them as sort of neural circuits. They learn very similar features across architectures and datasets. Now you can, in theory, actually do brain surgery on neural networks and recode weights by hand. With enough of these features interacting with each other and different activation patterns happening, you have these emergent properties start arising. At scale, these neural networks become really, really good at compressing because they're getting a large chunk of data with a lot of very common signals, and it can start exploring a lot of different kinds of patterns. Now, if you have a good enough world model that starts forming internally, you can start generating things, right? Because there's a point where things are interpolating and they start extrapolating after a certain size. And that is what leads to generative AI, really. So that is what we characterize as software 3.0. I was really excited about software 3.0 because in my head, the analogy I had was what the internet did for democratizing access to information, software 3.0 would do for knowledge. Now you've created a tool that amplifies knowledge workers. And we're still just seeing the early days. You know, people are more using ChatGPT's Wikipedia, which is the right way to be doing things. I wouldn't really be using that as a whole agent that you can go and rely on for work because that's too much. But this is where my development of software 4.0 and 5.0 kind of fit. And I've been trying to spin this and share this for a long time. 3.0 to 4.0 is going from a generative AI model that you can query with a prompt to a goal-oriented agent that is much more capable and can do a massive more set of work. If you think about vertical SaaS, you have a set of tools that you use to help you do work, and they automate life and make fun things a bit more easier. I believe software 4.0 is just going to be that. Now, you give it a higher level task, which it can decompose into a smaller set of tasks and work on them individually and or in succession, and come back to you with a full body of work that you have requested. If I have all my tax receipts and everything else, I give it and I'm like, hey, come back with something I can use for my filings. It does it all. It comes back and I have something. It's like, this is an estimated tax return. And now I can just go file that and I'm done. And it should be mostly verified. There's a lot of work before we get there, going onwards to 5.0. That is what I believe is going to be an autonomous agent. And this is where we really start seeing things like self-driving and robotics and all sorts of other really fun things. Again, the transition all the way 1.0 to 5.0, we realized a lot of the value from 2.0. There's still a lot more to get eked out. 3.0 early days. We want to get to 4.0, eventually get to 5.0. If there is another progression after that, I don't know what it is, but I'm excited to see what it is. As for what that means for applications and what that means for people and productivity, that's where it gets exciting. If you really think about how I gave the definitions, it is not about the capability of the model itself. That's a big part of it. The thing that really changed was how you interact with the model. From a human-computer interface point of view, instead of breaking down every single task into a succession, you coarsen it up a little bit and you give it something a bit more high level every single time. Now, instead of giving it an image and hoping for a class, you're like, generate me an image given this input. So you've done backwards. I have a higher level task that is more complicated and it comes back with more. I can tell it to go run and pick me up something from the grocery store. So the interface is what's really changing and you're getting more capabilities underneath. That becomes really exciting. Now, humans don't really have to go and become specialists. Everyone can be a generalist and get augmented with these capabilities of these agents that amplify them to do more tasks. So you're unlocking human capability at every single stage. So I don't see us as humans getting out of the loop. I see it as humans still being in the loop and we're being augmented and amplified. That is a future I'm really excited to help build.
I like the way you see the future. At the same time, there's safeguards that need to be put in place, and it's happening. So you have worked in a variety of verticals, various levels of abstraction. Where would you say you learned the most? Which one was the most enjoyable part of your journey so far?
I have had so many diverse experiences, so many different kinds of people that I've worked with along the way, and each of them have some way left a mark, and I've learned something from them. So I don't want to take away from them by picking one. I'll give you an example. Right now at Lemurian, I've been really, really fortunate to have built the team that I have. This is a team that's been doing cutting edge work all across the stack for almost 40 years. And so it's a very experienced team that have seen multiple transitions in technology. I have read about most of the work that they did. So I studied the outcome of their work. The amount of things that are missing in all these books is what I get to pick from them. The assumptions that they had, what at that time caused them to make these decisions, that is extremely rare. That's not something you can get in a book, really. I love books. I am one of those ridiculous people that reads a book a week. And I love books in general because it's the funniest thing in the world that you can summarize a person's entire life and knowledge they've picked up in a few hundred pages, and you can probably pick that up in a week. So you're living multiple lifetimes in a year. Yeah, I don't know if I can really pick one. The thing that really, really set in stone who I am as a person is probably my experiences as a swimmer. The discipline that gave me and the boldness that gave me to go after things. That's where we had the biggest impact. I was 16 years old when I qualified for the Olympics. I was still in Pakistan at the time, and that largely helped me get out of Pakistan into university in Canada. The discipline of waking up at 4 a.m. every single day, going for training before school, then going to school, then after school going back to training, then finishing out with my homework, spending time with family, going to sleep, and doing that for 4 years back to back in a row, no days off. That changed me and my mental chemistry to the point where I can't really stop competing, and I'm constantly trying to level up. That has a bigger part to do with it. I've been really, really fortunate to have been working with amazing people that have constantly taught me things along the way.
That's an amazing story, Jay. You have done so many different things. As a CEO, it must be tempting to try to do everything by yourself. How do you hold back and focus? And what do you focus on so that your whole team can be productive and you can get to where you want to go?
Truth is, I'm still learning. For a long time, I spent my time solving problems, actually writing code, and now I have a team that answers to me. It's not always easy relying on somebody else and delegating and think, go do it, when a lot of time how to do it also. But better because you've worked on the thing. Because you don't know it, but it's a fascinating enough problem that you really do want to do it. So it's hard, but we have an internal agreement in place on roles and responsibilities and who should be doing what. There's a lot of things that if I go and start writing code, I am not doing that is detrimental for the company. So I started creating a priority list of what are the things that I need to be doing on a day-to-day basis and all the things that have to be done in the company. There's obviously people that are really, really good at it and they have been hired to do those works. So we do them. Whenever I do have ideas on things how it should be done, we have a weekly meeting where we go over everything that has been done in the company. All the decisions have been made to see how we can make it better. I do work on coaching all of my team now on how I like things being done. If I do think something should have been done a different way, we can always go back and revisit it. Yeah, I'm still learning. I'm only scratching the surface on how to actually be good at delegating, which is good because the team is small and we are planning on growing very soon. So I have a lot of work cut out for me.
Yes, we are all lifelong learners, and there are times when the learning becomes very important. You mentioned about the need to compete, and you've done really well so far. Do you see your startup or your work as a sprint or as a marathon? Because if you're sprinting, you can go at 100 miles per hour the whole time, but there's
Yeah.
only so far. Or do you take
Well,
time to slow down and take a breath?
most impactful thing that was said to me was by Reid Hoffman. And it was, a startup isn't a sprint or a marathon, it's a marathon of sprints. That is so true. You do one thing, you're on to the next, you're constantly just switching and going on to the next thing. That can burn people out if not done well. Because of my sports background, I'm pretty fortunate that I know how to deal with stress really well. But you do need to have moments where you actually do sit down and calm down. If you're trying to fly through things as quick as possible, you're going to make mistakes. And the reality is most decisions can wait. It's one of the curses of being an entrepreneur that you believe you can do everything. And I do have that. There's no problem that is insurmountable. Moonshots are the business of entrepreneurs. That's what we live for. There's a lot of small problems. You want to let fires burn. They aren't going to kill the company. And you need to be really, really thoughtful about, is that a problem I should be taking on, or will it resolve itself? What is the bigger one that I should be going after and focusing on? There's been a lot of this been written about in different books about this. For example, Jeff Bezos used to say, I'm happy if I've made 3 good decisions in a day. That's a manageable metric. You have a staff of people, they're equally adept and they can also do things. But there are things that you're uniquely suited to do, and that's where you should be focusing.
Are you the same person that you were when you started in the industry? How has your work transformed you?
I don't think I am the same person. I don't think I could be the same person. At every single phase, I've learned something new that has made me question something that I thought was true. There's this saying about platforms, people are no different. If you think about every single platform shift that has happened throughout history, you didn't replace the old one. You took the new one in a different form and you added things around it. As you are growing through life, and you are growing, hopefully, you are evolving as a person because you are learning new things, you've had new experiences, you've had new failures, and hopefully you've had some glorious failures that have really made you question things. One of the saddest things in the world is playing it too safe and not failing enough. That is where real change happens. And that's where learning happens. I don't believe I'm the same person. Even from a neural perspective, every few years, the brain rewrites about 30% of itself. Within 10 years, I don't believe I could be the same person.
Certainly, Jay, you're on an exciting journey. And I'm so glad you have the humility to talk about some of these things and to be vulnerable and say, yes, there's change. Yes, there are glorious failures. Jay, how did you come up with the name Lemurian Labs?
As I mentioned, I really, really like big problems. When I was thinking about starting Lemurian, I knew that I was wanted to go after something big. Trying to rethink semi for AI and doing all these things is not a simple task. I went back to a story that I had read about when I was a kid. I was really into sci-fi. One of the stories was of Atlantis. Digging in, I found that the story of Atlantis had actually been misattributed. So Atlanteans were really politicians and all the high society folks, royalty. There was Lemurians, which were the scientists, the free thinkers, all the other heretics kind of just pulled into that one little island. They had been gifted knowledge. There was a third faction. They were the warrior working class. The Lemurians really believed that knowledge and technology and everything else should be built, cultivated, and grown for everybody to benefit from. The Atlanteans at the time saw this as a threat to their power, and they wanted to put a stop to that and put guardrails around it on who could access it and how. There was massive disagreement between Lemurians and Atlanteans at the time. The saying generally goes that resulted in a thermonuclear event and everything was lost to us and so on and so forth. That aside, what I took away was if you have a sufficiently powerful technology, there will always be forces that want to control it and others that want to set it free. That technology inevitably will find a way to be free. You might as well just start there. If I am working on rethinking compute for AI to make it equitable so that we can have the future that I spoke about earlier, I want to have those values embedded in the company. And I wanted to have a name that reflects that. I was very lucky to the fact that the name Lemurian was available. So I went and named the company after that. The entire culture, the ethos, and everything we do is very aligned with that kind of thinking.
That's awesome. It's amazing to hear what inspired you to give that name.
That people didn't know the name because, again, the domain name was available. The labs part was really just there because we want to have that culture of experimentation and trying new things out. The thing about moonshots is you're more likely to fail. This has always been true in any big kind of a project. You will always have more experimentation and engineering, and you have to create the right balance between the two. So you can take ideas, put them into engineering really fast, and have a fast iteration loop on top. So you're constantly getting better and better and better and better. We went with Lemurian Labs because we wanted to build something that was great for everybody. But we also want to have a culture of failing fast and learning fast from it.
This is why I talk to people to learn from them. I don't have a crystal ball. We're all learning together, and hopefully we'll create a glorious future through all these glorious failures. I'm so glad you're doing the things you're doing and are willing to learn and accept when things go wrong and move forward. So all the best, all power to you. It's been a joy seeing your journey over the last couple of years. And to people out there, there's so much to learn with each other, from each other. So please come forward. I want to know your stories. I want to know where we are going as humanity and how we can build much more harmonious future, which is much more inclusive. And I sure hope, Jay, you can build that hardware platforms that will make it possible for everyone to benefit from it. It is a joy talking to you again.
Thank you.